Algebra B. Wanted to give you guys a little example in the video today of how to do your 6-1-6-2 practice. So I'm going to go through 3 problems with you. I'll kind of do one factored form graphing, one standard form graphing, and then number 7, which has you factor it and then answer some questions about the parabola's characteristics. So let's take a look. We're going to start with number 1. Number 1 is an example of factored form. So just to kind of remind you guys, factored form, the general equation, you can write f of x or you can use y, but it breaks it up into these factors, x minus p and x minus q. These then represent the x-intercepts. Okay, so step 1 is going to be always to find the x-intercepts. So here, if x plus 3 equaled 0, that means if I subtract 3 over, x would be negative 3. So one of my x-intercepts has to be at negative 3, 0. Or we could say x minus 1 equals 0. If I added the 1 over, that would be at x equals 1. So now I know I have my x-intercepts at negative 3, 0 down here and 1, 0. Okay, we know the axis of symmetry has to be halfway between those. So our next step here, step 2, would be to find that axis of symmetry. That has to be halfway between these. So the other day I just counted, right? If we just kind of cancel these out, we see that halfway between here would be at negative 1. So I have my axis of symmetry is at negative 1, so you can put in the dashed vertical line at negative 1. And then we also know the vertex has to be on that line. So now I can find the second part of my vertex by actually substituting negative 1 in. So over here I'm going to do the work for the vertex. I know it has to be at negative 1 something. To find that, we're just going to actually plug negative 1 in. So you're going to do 2 times negative 1 plus 3 times negative 1 minus 1. This would end up being 2 times 2 times negative 2. And it's all multiplication. So 2 times 2 is 4. 4 times negative 2 is negative 8. So we get our vertex is at negative 1, negative 8. Okay. The other thing you need to find is 2 more points. So it doesn't matter to me. I think an easy one to find would be the y-intercept. So you might want to add in here, you have to find the y-intercept. That happens at 0. So we can just plug 0 into the equation like we did up here. So this would mean y has to equal 2 times 0 plus 3 times 0 minus 1. So that's going to be 2 times 3, which is 6, 6 times negative 1, which is negative 6. So you can get 0, negative 6, and then here you can see the reflection of the y-intercept. Once you have that, you can draw on your parabola. And then there's a couple more questions I just want to go over with you guys. So we jumped over this which way it opens. So deciding on which way it opens and deciding if it's a max or min has to do with your a value. So since our a value is 2, which is positive, that means that this is going to open up, as we already saw when we graphed it. And if it opens up, it's going to have a min. And then I want to look at domain and range as well. Okay, so this is review from earlier on in the year. Domain represents your x values. If we take a look at both of these arrows, they're going to keep going left and right. So for your domain, which is your x values, you're going to use every single number, which as a reminder, we say is all real numbers, or you can use that symbol, the capital R with the double stem. The range, we're talking about our y values. Here we have a lowest y value at negative 8, and then we're using everything above it. So we're going to use an inequality. So we say y has to be greater than or equal to negative 8. Okay, that was an example of factored form. Jump down to number 3. We're going to take a look at number 3. This is an example of our standard form, which again, standard form is y equals ax squared plus bx plus c. And now step 1 that we want to do is we want to find the axis of symmetry using our formula, opposite of b over 2a. So in this example here, the opposite of b is going to be negative 12. I'm going to divide that by 2 times a. My a value is 3. So negative 12 divided by 6 really gives me an axis of symmetry at negative 2. So I can draw on my dashed vertical line at negative 2 to show that's my axis of symmetry. I can also fill that into our problem. After we find the axis of symmetry, step 2 in standard form is to plug it in to find the vertex. So I know the vertex is going to be at negative 2 something. We need to actually plug this into the equation to find that. So y has to equal 3 times negative 2 squared plus 12 times negative 2. Negative 2 squared is 4. 4 times 3 gives me 12. And then 12 times negative 2 is negative 24. So we really get negative 12 here. So my vertex is at negative 2, negative 12. From there, I can find the y-intercept. The y-intercept is actually going to be pretty easy for us. It's always 0, c. In this case, we don't have a c value. So in this example, this is just going to be 0, 0 that I have my y-intercept. That also means I can find the reflection of the y-intercept. So if I'm 2 to the right of the axis of symmetry, the reflection has to be over here. At negative 4, 0. And we just need 2 points. So the last thing we did on this to find our last 2 points is we just organized a t-chart. So I'm going to put the vertex in the middle here, negative 2, negative 12. I know my y-intercept was at 0, 0. The reflection was negative 4, 0. So the last points I can fill in here are negative 3 and negative 1. If we want to find out what y is going to be for negative 1, I'm going to end up doing 3 times negative 1 squared plus 12 times negative 1. Negative 1 squared is 1. 1 times 3 is 3. 12 times negative 1 is negative 12. This gives me negative 9, which means this also has to be negative 9. So we end up getting negative 1, negative 9, and negative 3, negative 9. Then we can connect those to make our parabola. That gives us enough points to make our parabola. And let's go back and let's talk about some of these other characteristics I jumped over. So the first thing it does say, it wants you to factor. The other option you have here is that you could actually take a 3x out of both of these, and you'd be left with x plus 4. That is another way we could do that. We could find our x-intercepts then. The x-intercepts would be at 0, 0, which we already knew. That was also our y-intercept. And then it would make negative 4, 0, which we found was our reflection of our y-intercept. So you had a couple different ways that you could do this one. Talk about which way it opens. Our a value was 3. That's positive, so we know that this opens up, which we saw in our graph. If it opens up, we know it has a min. The domain is our x values for all parabolas. That's going to be all real numbers. And the range is going to change depending on your vertex. So now our vertex was down here at negative 12. That means our range has to be everything greater than or equal to negative 12, because the graph goes up on the y-axis and the lowest number was negative 12. Okay, that's an example then of both factored form and standard form. The last thing, I'm just going to go through an example with you on the bottom of the back of the page. It gives you a standard form. It wants us to put it in factored form, find the x-intercepts and the axis of symmetry. So the first thing we want to check for is a greatest common factor for factoring. There is none. So next we'll go to our x puzzle. I have 2x squared and 3x, which means my two factors are going to be 2x and x. I'm going to use grouping. So I'm going to rewrite this as x squared plus 2x plus x plus 2. Split it in half. I can factor out an x from the first half and just a positive 1 from the second. And so this gives me my factored form of x plus 2 times x plus 1. If that's true, the x-intercepts then either x plus 2 has to equal 0 or x plus 1 has to equal 0. So if I subtract 2, that tells me one of my x-intercepts is at negative 2, 0. If I subtract 1, I know my other x-intercept is at negative 1, 0. And then the last thing is find the axis of symmetry. The axis of symmetry has to be halfway between your x-intercepts. So if you don't draw it out, you can just add these together and divide by 2. So you could do negative 2 plus negative 1, divide that by 2. Negative 2 plus negative 1 is negative 3. Negative 3 divided by 2 gives me negative 1.5. So I know my axis of symmetry is in between negative 1 and negative 2, specifically at negative 1.5. Hopefully these examples helped. Finish up the rest of the review. That is your assignment. That is due start a class on Tuesday because you have a long weekend. You have off Friday and Monday.